Now, so since we're going to treat them equally, we're just going to follow the process that we use. We're not going to judge the fractions just because they look a little bit differently than the other numbers. Just follow the process. If you want to solve for x, we need to isolate x, correct? Well, we notice that I can undo this division or multiplication by 20, so I'm going to divide by 20. Now, I have 1/2 raised to the x over 3 is equal to 1 over 4. Now, we have a problem, right? We have x written up there in the numerator. Now, one thing that we did talk about is we can get rid of that x in the denominator by rewriting this as a log, right? We could rewrite that as a log. This is exponential form, correct? So could we rewrite this in logarithmic form? Yes, it looked like something like this. X over 3 equals log base 1/2 of the 1/4 power. Now, could you technically type that into your calculator using the change of base formula and then multiply by that by 3? It's not an exponent. It's the that's the base of the logarithm. That's where. So technically, you could do that. You can convert that over. But I also want you guys to understand something. When we have fractions here, we could also use the change. Remember I talked about the 1-to-1 formula? So you could use the 1-to-1 formula. For instance, first of all, let's not talk about fractions. Let's get rid of the fractions. So I'm going to do -2 to the negative first x over 3 equals 4 to the negative first. Now, to use the 1-to-1 property, though, the bases have to be exactly the same. Just put it right there. So in this case, our bases, put it right there. And if you guys would walk around that way, that'd be great. Can you guys see that the bases are not the same, right? Can we rewrite 4 as a base 2 raised to a power? Yep. Yes. So well, now that they have the same bases, what do we know? We can just set the numerators equal to each other, right? Or, I mean, the powers equal to each other. So therefore, we have -x divided by 3 equals -2. Now, to solve for x, I'll just multiply by -3 on both sides. And I get x equals +6. No calculator needed. Where do you get confused? I needed remember the 1-to-1 property. If b raised to the x equals b raised to the y. 4 and 2 are not the same. But I can rewrite 4 as 2 squared. Because 2 squared is the same thing as 4. And then using the power rule of exponents, I multiplied 2 times -1. Well, this is raised to -1, but then I had to rewrite 4 as 2 squared. So then those two multiply. Just like how I had to multiply -1 times x over 3 gave me -x over 3. Then the 2's, then we just multiply them. I was just showing you that's another way. But that's what I'm going to do in the next problem, is showing you guys you can